All right, guys, example 4, last one in the log unit here. So f of x equals 2 times log base 4 of x minus 5. So the first thing I want you to say to yourself is, okay, the base is 4. You're right. So the parent function must contain log base 4 as well, okay? Then before you guys even plot it into your chart, rewrite it. 4 to the y equals x. These two are equivalent. When I say equivalent, meaning that, hey, they are going to give us the same exact x and y values. They just look different from one another. So x and y, let's make a chart here for the parent. We will pick our 5 values for the input. Exponential tends to be a little bit easier to plug in, so that's why we're writing it in exponential. The first x is going to be 4. Then we're going to raise it to negative 2. That's going to be 1 over 4 squared. So that's going to be 1 over 16. Okay. 4 to the negative 1 is going to be 1 over 4. 4 to the 0 is 1. And 4 to the 1 is 4. And I'm missing a 2. 4 to square is going to be 16. These are all of the values for the parent function of y equal log base 4 of x. 4 to the y equals x. They will give us the same exact inputs and output, except that we write it in exponential because it's easier for you guys to go and find the table or make the table. All right, a is going to be your 2 because that's in front of log. Your h is 5. We don't have a k value, so we write it in as 0. So h and k is going to be 5, 0. K is 5, y'all, meaning that you're translating it to the right by 5 units. So your transformation for a is going to be a vertical stretch factor of 2. Okay, so factor of 2 meaning that we are gonna go and multiply all the y value by 2. The h is going to be the right 5 units. Okay, right 5 units. That will allow us to also go in and make the vertical asymptote at x equals to 5. Yep, you can totally do that. Okay, so now x plus 5 because h is 5. K is 0, so I don't need to add to the y value here on the transform table. Okay, so slowly we are going to take all of the x here and add it to 5 here. So 1/16 plus 5 is 5 and 1 over 16. 1/4 plus 5 is 5 and 1/4. 1 plus 5 is 6. 4 plus 5 is 9. 16 plus 5 is 21. Then we're going to take all of the y values. Let's use this. Okay, all the y values and transform it by multiplying by 2. Negative 2 times 2 is going to be negative 4. Negative 1 times 2 is going to be negative 2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. So now I will go and plot the dots, okay? 5 and 1/16 go down to negative 4. 2. Let me make my grid a little bit bigger so I can plot. Okay, next is 5 and 1/4 go down to negative 2. 6 is now 0. 9 is positive 2. And 21, as you can see, this is a 10 by 10 grid. So 21 is like, okay, all the way over to the right. I'm just gonna kind of eyeball that dot. How about right there? Is that okay with you? Connect the dots. Okay, make sure you guys connect the dots. I do see in your notes that some of you don't connect your dots. Okay, so arrows on both ends. Let's fill out all of the stuff that we can fill out without doing much work. X-intercept. Whoa! For this time, we can definitely just fill out the x-intercept, which is 6, 0. Y-intercept, we do not touch the y-intercept because, as you can see, we're all the way to the right. The domain is going to be, as you can see there, it has to be bigger than 5. So 5 to infinity. The range is going to be always all reals, okay, for log functions. It is increasing over the entire domain, so 5 to infinity. That means nothing left for decreasing. It is 1 to 1. We don't have a horizontal, but we do have a vertical at x equals to 5. For this one, everything seems like it's going okay because we don't have to do algebra or solve it manually for the x or y intercept. Okay, that's it, guys.